2, where we'll be focusing on the basics of probability. In Lesson 1, we're going to be focusing on the basics of the basics. We're going to be laying down the foundational work for all of the advanced probability we'll be doing later in the class, but we have to start with baby steps here at the beginning. Probability is the measured likelihood of an event occurring, and in our class, we're going to learn how to measure that likelihood. In our class, the letter P typically represents the probability. We often use words or other capital letters to represent specific events. So when you see something written as P parentheses A, that's really saying probability of the event A occurring. Mathematically, this is pronounced P of A. One of the best ways to understand probability is to understand the simplest of the formulas. The classical approach says that if an event can be separated into n number of simple outcomes and s number of those outcomes count as event A, then s divided by n would represent the probability of that occurring. Let's say I take this to the real world. Imagine I have a wheel that has 16 slots that are all evenly sized. One of those 16 slots say jackpot. So when I spin the wheel, the ball can land in any one of those 16 spots, and since only one of those slots says jackpot, I have a 1 out of 16 chance of getting a jackpot. Now imagine I change the question to, what's the probability of winning money? Well, there are 1, 2, 3, 4, 5, including the jackpot, 5 slots that say win money. So 5 out of the 16, meaning I have a 5 out of 16 probability of winning money. What the classical approach says is however many possible outcomes there could be, 16, goes in the denominator, and however many of those outcomes count as event A, which in the first case was jackpot, and in the second case was win money, that number goes on the top. Then you divide and you have your probability. Before we move on, let's make sure we're clear on a couple of the rules about probability. Probabilities can be given as fractions, percentages, or in our class, we'll use decimals. The probability of an impossible event is 0, so you can never have a probability below 0. The probability of an event that is certain to occur is 1, which means 100%. You cannot have a probability greater than 1 either. That means that all probabilities are bounded between 0 and 1. The last point I want to make is about rounding. My preference is that you always round your answers to 3 decimal places, although there are some exceptions in special problems. Now for some examples. In probability, we're often going to do problems using a deck of cards, as it gives you a nice variety of options. So there are some things you're going to need to know. There are 4 suits: hearts, diamonds, spades, and clubs, and there's 13 cards per suit. The ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then the jack, queen, and king, which are called the face cards. Since there's 4 groups of 13, that's where we get the 52 cards in the deck. Our first question is going to ask us to find the probability of selecting the 7 of diamonds, an event that they've named event D. So we're trying to find the probability of D. Well, since there's 52 unique cards in the deck, that's the number of possible outcomes. So I'll put that in the denominator. The 7 of diamonds is a very specific card, and there's only 1 of them in the deck. So the probability of event D is going to be 1 out of 52, since there's 1 7 of diamonds out of 52 cards. Now I'll go to my calculator here to get a decimal answer. And I get an answer of 0.192, rounded to 3 decimal places like I instructed. Now the next question asks us the probability of selecting a diamond. They've called that event E. Well, as we said, there's 13 cards per suit, so there are 13 diamonds in the deck, again out of the 52 cards in the deck. Turning that into a decimal, we get 0.25, and that's our final answer. Our next topic is complementary events. Another word for complement is opposite. The opposite of an event is all other outcomes that aren't that event. This gives us a really easy formula. Since all of the outcomes in a sample set have to add up to 100%, if you want to know the probability of not being A, you just do 100% minus the probability of being A. Here's an example that applies that rule. We're told that on an SAT test, you have a 1 out of 5 probability of being correct, and they ask you, what's the probability of being incorrect? Well, incorrect is the opposite of correct. So if you know the probability of being correct, you can just do 1 minus that, and you'll know the probability of being incorrect, which in this case is 4/5, or as a decimal, 0.8. Let's end things with one other example. We're told that an insurance company determines that in every 100 claims, 4 of them are fraudulent. So 4 out of 100 are fraudulent. So they're asking us what's the probability of being fraudulent? Well, the probability of being fraud is how often we assume there will be a fraudulent, which is 4 out of how many events will occur, which is 100. This gives us a decimal answer of 0.04, and the problem's finished. To summarize, probability is a measurement of the likelihood of a certain event occurring. The simplest way to understand this is by taking the number of favorable outcomes divided by the total number of possible outcomes. Although, as we'll see as this unit progresses, that will become more challenging and in some cases impossible, so we'll have to learn other methods for finding probability. If you came away with anything else, write that down now, otherwise we'll see you in the next lesson.